Oh, thank you. I'm going to go ahead and get started. Yeah, my name is Meg. I am currently a staff UX researcher at a company called Intrinsic AI. Let me advance my slide. At Intrinsic AI, it's an alphabet company, and our mission is to democratize access to robotics. I have a little over a decade of experience as a UX researcher, and I've spent probably the last 5 years have been in the robotics and AI space. And one of my previous roles and what I'm really passionate about is about explainable AI. And today I'm going to be going over some of the human factors for explainable AI. Here's an outline for my presentation today. So I'll be talking about what is the actual need for explainable AI, why is it essential for the adoption and growth of machine learning, some of the human factors. So when we consider the different audiences or end users for explainable AI, what are their needs and some of the human biases we all have. I'll give an example of how we already explain complex things today. So I'll give an example from a past experience where I was working on weather data, which is actually an example of forecasting and predictions where we actually do a pretty good job of explaining how that works to end users. Then I'll go over into some of the UX of XAI recommendations I have, and covering a lot of examples of interactive XAI in particular. And then I'll have at the end all of these slides I'm going to share with you, and I'll have some resources in case you want to learn more. So just to get started, what do we even need XAI for? So this is a great quote that I think summarizes it. It's the dangers in creating and using decisions that are not justifiable, legitimate, or that simply don't allow obtaining their detailed explanations of their behavior. So a lot of times we need an explanation of a prediction in order to even use it, so the utility of it. In particular, explainable AI is very important when you think about the development of machine learning systems. So how do you assess it? How do you optimize it? And certainly, how do you troubleshoot it? So like when your machine learning system goes wrong, you're going to need something that can explain its behavior in order for you to sort of figure out why it's arriving at illegitimate conclusions. But also you can use explainable AI to help with your feature optimization. So if you can see what your model is relying on, you can sort of trim down your data pipeline to sort of be its most efficient. It's also very important, I'm sure this is a topic a lot of you have heard about, but in terms of assessing fairness and addressing bias. So as we all know, like models can arrive at unfair or discriminatory bias decisions. And without XAI, it's awfully hard to figure out, to analyze that and actually identify it. So XAI is important in that domain. But also just in end user adoption. So in general, we are reluctant to adopt things that we don't understand. So if you can't understand it, it causes you to hesitate in terms of adopting a new tool. So XAI is very important for the end user experience. And also sometimes in order to actually use an ML prediction, you need the explanation behind it. So one example is, if you were thinking of a digital pathology tool where a machine learning model made a prediction, a pathologist is probably not going to just take what the ML algorithm gives for granted. They're probably going to wonder why it came up with a certain diagnosis or a certain prediction so that they could better do their craft as a doctor in that situation and coming up with a treatment plan for their patients. So often XAI in and of itself is an output that end users will need. So some of the human factors to consider is, depending on who the audience is, they're going to come to that experience with different domain expertise, different cognitive abilities, and they might be in a different context of how they're going to be using it. So if you take, for example, that digital pathology situation where you have a pathologist who's using a machine learning model to help with the analysis of data that they've gathered from a patient. In that scenario, you're going to have somebody who's like the data scientists and model builders who helped build that digital pathology tool. They might be an expert on machine learning, but they're probably not an expert on pathology. So they might not understand how the data is gathered, how reliable the data is, those type of things. On the other hand, you might have the pathologist themselves who probably is an expert on the data. They probably have a very fine-grained understanding of what the data represents, but they might not be an expert on machine learning systems in terms of understanding the reliability of those predictions or what could go wrong in that type of domain. And then you have the end user, the patient in this scenario, who may be not an expert on machine learning and not an expert in pathology data, but they're still very much affected by this whole system. And they require explanations as well. So when you think about the types of explanations these people will need, probably those explanations is not a one-size-fits-all scenario. The machine learning scientists or data scientists will probably need different information if they're, for example, doing a troubleshooting analysis. A pathologist is probably going to need different information if they're coming up with a new prognosis or a treatment plan. And the patient is going to need a different format of explainable AI in order for them to just understand what this system has produced for them. And all the people in these scenarios are all human, so they're all subject to human biases. And there's a number of biases that we all have that sort of affect the way we may interpret a machine learning output. So I'll just go over a few. One is anchoring bias. This means that you tend to rely a lot on the first piece of information you're given about a topic. So this can be used almost maliciously, in fact, to sort of anchor your bias around a certain price point. So if somebody tells you a t-shirt costs $50, that is now your first piece of information about t-shirts. If somebody then says, but I have this other t-shirt that costs $40, you're going to think to yourself, that t-shirt's cheaper. And you're going to think of it in terms of less expensive. But that's because you've been anchored on the higher price point. So that's one way anchoring bias affects us. Availability bias also is our tendency to believe that the examples we see are representative of the whole world. So you might have a very limited set of data, only a few data points, but whatever you observe in that, you might think is sort of general of the whole population. So you're sort of subject to sampling bias in that and in your interpretation of it. Another type of bias that's very relevant in this domain is confirmation bias. So we tend to seek out information that confirms our prior beliefs, and we tend to be more critical of information that goes against our beliefs. So if a machine learning algorithm turns out a prediction that is in line with what we would expect, we're not going to interrogate that model as much as we would have if it produced a result that was different than what we expected. So you find you actually do more interrogation and deep diving if you were the data scientist per se, when the model comes up with predictions that are different. And then this can all result in unjustified trust or overtrust. So sometimes people will have higher degrees of trust than they should when explanations are presented in different formats. And there's actually a really fantastic study that I linked to here, where they gave AI experts as well as non-AI experts different types of explanations. In one scenario, they were given a sentence, like a human readable sentence. In another scenario, they were given a mathematic equation looking explanation. And both groups, regardless of whether they were experts or not in AI, had more trust for the mathematical representation than a human readable sentence. So it lets you know that the form factor of the explanation itself can actually influence the degree to which you trust a machine learning model. So now that all sounds sort of scary, actually, when you put out all the human biases out there. It sort of seems like this is an impossible scenario of explanations. And I'm going to go over one example that I worked through when I worked at a company called Weather Underground, and we were working with weather data. And then in the rest of the presentation, sort of what I want to put forward is that adding an interactive component to explanations can actually make it sort of conquer some of those biases and make it easier for end users to come to the accurate level of trust in a machine learning prediction. So time for the example. So weather data, sort of like I alluded to before, is one of those domains where we've actually been using machine learning for quite a long time. You've probably all encountered weather forecasts that's based on machine learning. And we've been putting that information in the world, and people have been end user consumers of that type of prediction for a long time. And there's lots of different ways you can put that information. When I was working at Weather Underground, though, I was specifically looking at radar data. This image doesn't have a lot of radar data, but we were dealing with some feedback where people said that our radar imagery felt very inaccurate. And they sort of accused us of sensationalizing weather. They said that our radar maps made storms seem like they were stronger than they actually were, which is sort of an interesting piece of feedback. And one thing to know is that a lot of weather companies actually have the exact same weather data, or radar data, that is. So especially in the United States, a lot of companies draw their radar data from the National Weather Service that provides that data for free. But that data comes to these companies, and different companies can make different decisions on how it's presented on their system. There's no standardization of how radar data should be displayed on a map. So this is an example of two different weather websites displaying the same storm with the same radar data, but you can tell that they look a little bit different. The one on the AccuWeather side seems stronger, or maybe has more dangerous elements to it than what we see on the IntelliCast side. And radar data as it is sort of a not straightforward type of data. There's this dBz is the measurement they use, and it's on a logarithmic scale. And so it's not linear is what I mean to say. With linear data, you can sort of get these nice even ways to interpret the data. With logarithmic, it's a little bit harder. It's not on a sliding scale. So it's harder to just map it out in a straightforward way for users to understand. And so how I approached this particular problem, I was looking at how our users were interpreting our radar predictions and radar maps, and how they were coming back with the feedback that it felt like the storms we were representing were stronger than they actually were. And so the study I engaged in was asking those sort of domain experts, the meteorologists themselves, what does this data actually feel like, and have them describe it to me in qualitative terms. So essentially asking a meteorologist to describe what 36 dBz would actually feel like. And they would say things like solid rain, but not a downpour. So there's these words we use to describe an intensity of a storm. And I would do the same thing with end users, but I would actually show them different imagery. So I would say, what do you think this would feel like? And they used their own set of qualitative words. So they would say things like, I wouldn't want to be outside, or it might flood the storm drains. And I did a qualitative coding of different themes that you could get in those responses. And what we ended up seeing is that both meteorologists and end users experienced the language that they would use to describe a storm had significant jumps at certain levels of the data. So at going from 30 to 36 dBz or hitting 35 dBz, that was when meteorologists would start describing it as being something that you would actually want to prepare for. So a storm that was an intensity that you would actually want to do some prior planning. And then at 55 dBz, that's when they would describe it as actually being dangerous, where there would be property damage or different potential dangerous conditions for you as a human if you were caught outside or caught unprepared. And similarly, our users would have a big jump in how they describe things when they saw the color yellow and when they saw the color red. So in this study, I was trying to line up like where the changes in experience happen along the data or the way we predict, along with how we displayed it to our end users. And the result was a new palette. So this is the same storm, one with a new palette that we proposed and one with the older palette. And you can see that this On the new storm, it has much more green, much more subdued. It looks like maybe a calmer storm than the one we had on the right in the past. And when we monitored for user feedback, we found that people's perceptions of the accuracy of weather underground went up because of this change. So one thing that's sort of interesting about that is that we did measure a customer's perception of our accuracy. And these types of changes, the changes in how you display an explanation essentially of data, can change the way they perceive that. So I'm going to talk about sort of some of the UX factors involved in this. And there's this really great quote in this article that I link in the resources. And it says, what counts as an explanation depends on the user's needs, what knowledge they already have, and especially their goals. So I think one thing to have front and center is what the goals the user is actually trying to accomplish in whatever machine learning system you put out in the world. In the weather example, we had a very explicit goal that we wanted to make sure that our users accurately understood when dangerous weather conditions were coming their way. So that was sort of the goal we were trying to achieve with our explanation, and that's what we sort of measured ourselves against. And also along those lines, we wanted to make sure our users could make good decisions. So when they saw the prediction we were making, that they would make good decisions for their lives in that scenario. So sort of the question is like, how can we help our end users meet these goals? How can we help them make better decisions? And one interesting thing about decision making is there's actually a lot of research about how do humans even make decisions. And I don't know if any of you have read this book, but there's this fantastic book called Thinking Fast and Thinking Slow. And it describes different ways that we'll make decisions. So there's sort of system one thinking that they call it, which is our fast thinking. So we usually just have heuristics in our mind, and we'll make a decision sort of based on our prior experiences or the input we have immediately available. Whereas system two is more logical, more well thought out. You can imagine it as sort of like a research project. You do a lot of fact finding and evidence gathering. And they both have weaknesses though. So system one might be, you're subject to a lot of biases, but the advantage is you might do that type of thinking very quickly. Whereas system two, maybe you take you put more energy into interrogating the different decisions you could make, but at the same time, that takes time. And what's interesting is there's this really great paper, again, I link it in the resources, where they map out sort of the type of ways people reason and explain, the type of ways people reason and sort of do their thinking, and it maps out the types of biases you might encounter, and then it maps it to different explainable AI techniques that could help with that. So for example, if you're dealing with confirmation bias, you can mitigate that by doing prior probabilities and sort of showing the input attributions of a model explanation. If you are dealing with misattributed trust, you can do that by having more scrutable contrast. So doing different things where you can show things in contrast to one another can sort of help people draw the lines around when should I trust this system and when should I not trust this system. So this is sort of a fantastic way of thinking through that. And here's another table from that paper where they talk about specific biases. So here's anchoring bias, here's confirmation bias, and they talk about strategies to overcome these type of biases. So you can sort of almost look at this paper as like a recipe book of what are the biases my end users are probably going to be subject to, and what are some different things I can do strategy-wise to overcome them. But one other great quote from this paper is that the property of being an explanation is not a property of statements, it's an interaction. And actually when explainable AI has an interactive component to it, you find that you can overcome a lot of those biases too. And so in the next section, I'm actually going to show some examples of what interactive explainable AI could look like. So this is from a really great paper of where they were looking at what you might call example-based explanations, which is where you give input and then it shows you its nearest neighbors. And it can maybe map it out on a histogram or do different things. So in this example, we're having a machine learning model identify what object it is from a drawn image, and it'll show you, I predict that this is an onion, and here are all the nearest neighbors. So here's what all those nearest neighbors look like. And you can sort of see similarities just by looking at it between the images. But then what if I interact with it? What if I change something about my input image? Let's say I erase that inner circle. You start to see that you get more variation in the nearest neighbors, but also this other object called blueberry starts popping up. And when you erase the circles into all together, you get all blueberry and only one onion here at the end. And you can sort of see how the distribution of your nearest neighbors changes as you make changes to your input image. And it's sort of just through this interaction, it sort of clues you in as to what the machine learning model is grabbing onto to make its prediction. So it tells you like, oh, having these inner circles is sort of essential to the drawing of an onion, or at least how my model is interpreting an onion. And you could imagine a troubleshooting scenario where if your machine learning model was not providing the right label, maybe you could sort of play with the image and it would allow you to interact with it and understand more about what the model's doing. And in this paper, they have a really great quote where they talked about, you know, by having this method of interaction, users can discover or ask questions about the limitations of the data. And doing so, that doesn't damage trust, but it actually plays an important role of building it, because trust is not an on or off thing. Like when we're very used to systems having moments where they're very trustworthy and moments where they're very not trustworthy. We're okay with the fact that systems may have limitations, but we really want to know what those limitations are. So if you have a system like this, you can actually explore the boundaries of the limitations of the machine learning model and understand when it's going to perform well and when it's not going to perform well. This is another example of an interactive XAI system called the What If tool. You can go and play with it here. I have some screenshots, but one thing is if you do something like feature attributions, where you show the sort of feature attributions that a particular input has, you can sort of play with it with these slider scales and see how the output or the label your machine learning model gives changes based on that. So it's sort of, again, playing with the inputs to see how that changes the output. And here's a sort of GIF of the What If tool where you can sort of, it walks through how each of these things are different variables or features, and you can sort of see how it plays into the prediction, and then you can actually zoom in on a particular piece of data and it'll display for you the different attributes, and you can even change the attributes and see how it changes the prediction value. The next one is the language interpretability tool. The language interpretability tool is actually the successor to the What If tool. It's more focused on language, as sort of the name implies. And actually it shows you, it's sort of hard to see, but these are textual statements that it's made a prediction based off of. And when it shows you the highlighted values, it shows you which words in the text statement actually are heavily influencing the machine learning model. And what you can do is you can actually play with that by, let's say your model latched onto this word strength or something like that. You could actually edit the statement and take that word out, replace it with a different word, and see if it came up with the same prediction or if it changed it. So you can actually see from a language model which words in a statement are having the heaviest influence on the model prediction, and you can do it in this very interactive way. Here's another example. This one's called Smiley. This is very much like a digital pathology tool. This is using a technique called example-based explanations again, where you can do different levels of refinement. So you can say, if you're a pathologist and you get a slide, you can say, actually, the only thing that matters in this slide is this region. So I want you to focus on this. And then one interesting thing about the practice of pathology is that a lot of times if they're making a diagnosis, they want to find reference images. So they might actually go to textbooks or different things to find reference images so that they can find a similar example to what their patient has as sort of more evidence for whether they're making the right diagnoses or not. So one thing about this tool is by using that same nearest neighbors or example-based explanation approach, you can sort of zoom in or focus on a image that you want. You can say, give me more like this, and sort of find me the nearest neighbors to this. And then also it has these sliders where you can sort of, if there's real concepts that can be identified in the image, you can sort of similar to the language interpretability tool or the what if tool, you can sort of play with the values of different things to see how the prediction changes. And there's a sort of GIF of this as well, where the person's choosing a particular section of the slide that they want to examine. They're getting the similar examples, and then they can sort of do that and sort of understand what about this image the model is latching onto in terms of its predictions and what those nearest neighbors are. Pretty cool. And of course, I had to talk about ChatGPT. So ChatGPT is so fun to play with, just to ask for different things. And of course, I asked it to write an outline for this talk. But then I just asked it. I wanted to know what the explainable AI technique was for ChatGPT. And I asked it, how did you come up with this outline? And it was really interesting to me that it gave me that output almost as the same way it gives its model output. So it gave me a list. ChatGPT loves lists of all the steps it followed to generate that answer, which I thought was interesting. And what I thought was interesting about it is that the mode is text input for ChatGPT, and the same way that you would ask it for a prediction or for some output is how you would also ask for an explanation, which was interesting to me. Okay, so some parting thoughts. I just wanted to talk about how, again, interaction design is a cycle. So all of these components, all of these interactive components, it went through the cycle of interaction design where somebody had an idea about how you could interact with a model, they created it, but then they also did a cycle of evaluation. They evaluated it with end users. They uncovered problems or heard the questions that people had about the model. And then they went through the process again, where they saw what could they do, what could they change about the output. So I guess the takeaway from this is that it's not to come up with a good interactive explainable AI interface, it's not going to be a one or done, it's going to follow the cycle of interaction design. So being prepared to sort of go through the cycle a few times to really meet end user needs. And along that way, so an important component is evaluate. There's a lot of very established user-centric methods and measurement tools that you can use. So all of these things, understandability, satisfaction, utility, trustworthiness, there's actually a lot of published scales for how you can evaluate this. And it's sort of a part of UX practice to evaluate these things. And that's sort of it for like my final message. And then I have links to some resources. So there is one article I wrote explaining the unexplainable that's sort of like an XAI 101. So if you want to get some more base information about what explainable AI is and a few of these thoughts, you could go there. But also these are some articles I recommend for going into it. So that article that showed the onion versus the blueberries and how you can interact with that image is here, as well as sort of mapping out the thinking fast versus thinking slow to the different XAI techniques are here. And this article, Metrics for Explainable AI, Challenges and Prospects, really outlines some of those measurement tools that you can use when you're assessing explainable AI for how successful it is for your end users or whoever's going to be taking that machine learning model prediction and running with it. So I think that's it for my talk, and I would love to take questions if you have them. Feel free to put questions in the chat and I'll read them out loud. And I guess one other thing I'll say is, so yes, I work at a company called Intrinsic now, And on May 15th, they're doing their first ever product keynote, where they're going to be talking about what Intrinsic's been up to for a while. And you can RSVP for that keynote. If you're interested in the intersection of machine learning and robotics, I highly recommend you check it out. And I'll post that link in the chat. But yes, happy to take questions. Can you do explainability after the model is created, or is it too difficult to retrofit? That's a good question. There are, I wonder if I have a table I could quickly pull up. There are explainable AI techniques that can be done post hoc. So for example, feature attributions is something that you can get post hoc. So that's like after a model is built. It can be compute intensive because essentially it ends up querying your model over and over again to get sort of a distribution of the different predictions it's making. But it is something to, but then there are other XAI techniques that you would have to set up at the time of building your model. So things like example-based explanations or nearest neighbors explanations, a lot of times that'll take like the second to last layer of a deep learning model to build out a sort of data structure for all of those examples that then you're querying to get the nearest neighbors. So there are definitely some that are available post hoc though that you can start tapping into. So if you have a model that's already deployed out in the world and being used in an application, you can sort of look into that. And then what was the link? I cannot get into the chat. So there is like the ODSC conference chat room, but I'm happy to take questions here. And if you were asking for the link to the keynote, that's the link. And also I can share the slides. What do you think of Lime as a way to gauge explainability? Good question. I am, which one is Lime I'm thinking about? So, I'm forgetting which one is Lime, I'm gonna look it up real quick to make sure I have the acronym right. Oh, yes, so that's one of the model agnostic ones. So, one thing, like Lime is another one of the ones, I think it's related to sort of similar to feature attributions where it can pull out like what attributes helped contribute to the model prediction, I think if I'm remembering it correctly. And that is really helpful, especially in that scenario where you have like what they did in the language interpretability tool, where it can do the sort of highlighting of the text where and it can show you sort of the feature attributions of like what it's pulled out and then the highlighting of the text of what it pulled out. That can be very helpful to let you know what could be sort of sending your model towards one prediction versus another. So if it has some words that it's really latching onto, it can help you understand your model. But also if it's starting to latch onto words that you think are irrelevant for what the model is trying to predict. So I'm trying to think of an example. If you were doing some sort of sentiment analysis where you were trying to predict whether user comments were positive or negative towards a product and you were trying to come up with some kind of score, but then if you saw that the model was really latching onto the word packaging or something like that, that would tell you something that maybe it's associating the word packaging with a positive or negative sentiment, and it would cause you to do a sort of like deeper investigation of what's going on there. So a linear Perturbation. Oh, thank you for the explanation there. So I think those type of things can help you sort of do the playing with your model to figure out what exactly is happening under, what is rising to the surface in terms of what your model is latching onto, and that can help you do that sort of interrogation. It is a little hard for an end user though. So like if you were trying to come up with an end user explanation, it's hard to use that type of thing. It's more of a tool that's better for data scientists or sort of people who understand. Whereas, you know, my talk with ChatGPT, like this took nothing for me to get this explanation out of ChatGPT. So as like, it depends sort of on the form factor it takes. And you can see things like the Smiley tool has been designed specifically for a pathologist to interact with. And so I think it's not just the technique necessarily, but focusing on like the type of decisions your end user is going to want to make out of that. Okay. Thank you for that, David. Okay, are there any other questions? Okay. Well, thank you all so much for coming to my talk. If you have more questions, I would love to connect with you on LinkedIn. Here's my LinkedIn, or you can send me an email. These slides I'm gonna share, and yeah, I would love to hear from you if you have any more questions on this topic.